Let's talk about the temperature coefficient of a resistance. Now, we said in our previous video that one of the factors that affect and determine the resistance of a conductor is the temperature. Today, we're going to show a mathematical expression between the temperature and the resistance of a conductor. Now, take note. Let R0 be the resistance of the conductor at 0 degrees Celsius. Now, let also R1 be the resistance of that conductor at theta 1 degree Celsius. Now, let alpha be the temperature coefficient of the resistance at 0 degrees Celsius. Now, take note. The value of the resistance at theta 1 degrees is given by this expression. R1 is equals to R0 bracket 1 plus alpha theta 1. So let's call this equation 1. This is the mathematical expression for the relationship between the resistance of a conductor at 0 degrees. Of course, that is the reference. So we can call this the temperature or the reference temperature coefficient of the resistance at 0 degrees Celsius. Where this is the resistance of the conductor at 0 degrees Celsius, R1 is the resistance of the conductor at theta 1 degrees. Now, what if we have a conductor where R1 is the resistance at theta 1 degree Celsius, R2 is the resistance at theta 2 degrees Celsius, and we also have this as the reference temperature coefficient at 0 degrees Celsius. Now, take note. For a case where we have the resistance at theta 1 degrees with respect to the reference temperature, we know that this is the expression. So we're having this as R1 R0 bracket 1 plus the reference temperature coefficient multiplied by theta 1. So we have this as equation 1. In the case where we have the resistance at theta 2 is going to be equals to R2 equals to what? We reference to what? R1, which is the resistance of the conductor at 0 degrees Celsius. So this is going to be R0 bracket 1 plus the reference temperature coefficient multiplied by theta 2. This is going to be equation 2. Now, how do we find the relationship between these two resistance at two different temperatures? Now, take note. We are going to divide. So we are going to be dividing. So we are going to be dividing equation 2 by 1. So we're going to divide equation 2 by 1. So we're going to have R1 is equals to R0 bracket 1 plus the reference temperature multiplied by theta 1 all over R2 equals to R0 bracket 1 plus theta 2, the reference temperature multiplied by theta 2. So we are going to break this down. So we are having this as R1 over R2 is equals to R0 bracket 1 plus the reference temperature multiplied by theta 1 all over R0 plus 1 plus the reference temperature divided by theta 2. You will see that this will cancel this, and we have that R1 over R2 is equals to 1 plus the reference temperature multiplied by theta 1 all over 1 plus the reference temperature multiplied by theta 2. Let's call this equation 3. So you can see that this is the expression and the relationship between the resistance at theta 1 and the resistance at theta 2. Why this is the expression for the relationship between the resistance at 0 degrees Celsius and at the resistance at 0 theta 1 degree Celsius. Okay, now so let's get down to the sample problems.